In this riverboat problem, two stages are involved. First, the boat is steered at right angles to the river direction, but the river flow drifts it in the direction AC. You refer to the diagram. A is the starting point, C is somewhere in the middle of the river. So up to AC it is going in that direction, AC. It would have continued in that same direction to reach the opposite bank, if not for the interruption by the passengers to divert it to another place, that is opposite to the starting point, which is opposite of A being starting point, opposite that is B. So passengers want the boat to go to that in that direction. So now, because of this request, the boat is diverted at middle of river, which is the point C, to reach the opposite point B, steering, and for which purpose the boat is steered along another direction, vector CF, making some angle theta. Theta is marked in the diagram. So it is diverted in CF direction. River flow will further drift it in its own direction, making the final orientation along CB. So CB is the point where it has to reach. So in relative velocity problems, to know the time of journey, you divide the corresponding displacement by the net velocity in that direction. Displacement by net velocity in the direction will give you the time of flight. We have used, we have applied this rule for both stages. So on applying the rule for the stages, for the simultaneous displacement, EB vector and CE vector, you can see both displacements occur simultaneously in two different directions. By this, equating the time for the two displacement, we are getting an equation for theta. Now in this case, you take note that the river velocity has no component at right angles to the river flow direction. So when we take the time along, when we find the time for displacement along across the river flow velocity will not be involved in that. So getting that equation for time for C and EB, that equation will serve as the equation for theta, finding theta, and solving that we get theta equal to 53 degrees. So using this value for theta, we are getting the required time difference, original path direction and diverted path direction. For the time, the two times we find the difference, which is the requirement. Now with these guidelines, you should be able to follow the solution. Thank you.